Okay, Assalamualaikum and hi. So this is the chapter 5, Science Form 4. The topic is motion, but this one is part 1. So our topic here is a vehicle on land. So for 5.1, analyzing the motion of vehicle on land. So actually, on the land we have two type of vehicle, which is a vehicle without engine and vehicle with engine. So first thing we will learn about the vehicle without engine. So this vehicle everybody experience cycle it, right? So many vehicle did not use engine to move about. So for example, bicycle, bulldog cart, wheelbarrow. Okay, so this one we consider as a vehicle without engine. So the bicycle use human energy on pedal and move it. So girls, you have to remember or able to label the part of a bicycle. So you have the saddles, right? Pedal, the place that you put your foot, right? And the metal chain, which is connected from the sprocket to the the behind wheel, right? So we have the brake lever, brake pedal, and hub, girls. So when you pedal your bicycle, so automatically by this will transfer the rotation to the hub, which is at the behind wheel. So automatically your behind wheel will be rotate. So your bicycle able to move forward. Okay. So now we learn about the the vehicle with engines. So many type of vehicle have engine which move them. So four-cylinder engine is commonly used in the motor vehicle. So a fuel is burned in the engine to move the piston. The up and down motion of the piston causes the shaft in the vehicle to rotate and the wheel to turn. So this make the vehicle to move. Okay, now study the diagram. So this is four-cylinder engine. Okay, so you look at the diagram, you can see the cylinder. So it's the place for the fuel to enter. You can see the piston which is able to moving up and down, and you have the spark plug in the valve and the outlet valve. And down there you have the bearing and the crankshaft which is able to rotate. Okay, so how this engine. Okay, actually we have two type of four-stroke engine. One is petrol engine, the other one four-stroke diesel engine. First of all, we going to learn or to study the petrol engine. So generally in the four-stroke engine we have four stages of stroke. Okay, we have the induction stroke, compression stroke, power stroke, and exhaust stroke. Okay, we go one by one. Okay, the first one, the piston. Okay, look at the diagram. You have here the air and petrol vapor were injected inside the cylinder. So to allow this petrol and air to enter, so this inlet valve will be open, and the exhaust valve will be closed. So to prevent this petrol from move outside from the cylinder. So this piston will be joined to the crankshaft. Okay. So what exactly happened in this induction stroke? The piston move down the cylinder to provide the space for the warm air and petrol to enter. And the inlet valve open and exhaust valve closed. The mixture of air and petrol vapor enter the cylinder through the inlet valve. So this is, we call it as the induction stroke. So you have to remember the word induction. So the This is the stroke where the petrol and air will be injected into the cylinder. For the second stroke, we call it as the compression stroke. So when you talk about the compression, right, of course you can see the piston moving up, okay, and these two valves will be closed. So if these two valves still open, of course the compression cannot occur, okay. So both valves are closed, the piston move up the cylinder to compress. Of course the volume of cylinder would be smaller. The mixture of air and petrol vapor is compressed and heat up. So where come the heat, right? So actually the petrol and the air, they have their own particle. So when the small volume, it will cause the particle to collide between each other. So the collision of this particle will produce heat. Okay, so the heat comes from the collision of the particle in the small space. Okay, so now we go for the third stroke, is a power stroke. You remember the word power. So here come the powers. Okay, here you can see the spark plug, spark to light up the fire, right? Then spark across plug inert fuel. Okay, you can see the piston move up. Okay, back to the explanation. Both of the valves are closed, right? And the spark plug produce a spark, ignites the fuel and cause an explosion. So when the particle is compressed and heat up, and you give the spark. So what happened? There is the explosion occur. So this force that come from the explosion of the expanding gases will drive the piston down. So that is the power stroke where the explosion occur in this stroke. The fourth one is the exhaust stroke. So you can see here the exhaust valve will be open to allow the gases, exhaust gas, to out from the cylinder. Okay. Now the exhaust valve open and inlet valve remain closed. The piston move up and drive out the exhaust gases through the exhaust valve. So when the exhaust gases move out, that means the pressure inside the cylinder is much more lesser. That's why the piston move up. Okay, the new cycle start when the piston move down. So girls, this is all the 4 stages of the 4-stroke petrol engine. You have to remember induction, which is the injection of the petrol and air. Second stroke, compression, where this part the compression occur and it will force heat. Okay, then third one is power stroke. There is occur the explosion. Exhaust stroke, when the piston move up and the exhaust gases will push outside the cylinder. Now this is how the 4-stroke engine, diesel engine work. It also have 4 stroke. The name of stroke also the same: induction stroke, compression stroke, power stroke, and exhaust stroke. Okay, now you look at the diagram first. The exhaust valve is closed, the inlet valve is open. So of course this is the induction stroke. The inlet valve will be open to allow air to enter. Here only air will enter. Just now in the petrol, air and the petrol will be entered. So the in the cylinder, and the piston will move down. Okay, so the inlet valve open and the valve exhaust valve is closed. The piston move down of the cylinder to give the space for this air to enter. Air enter the cylinder due to air pressure. Okay, now go to the compression stroke. Okay, compressor stroke. Look at the diagram first, then you can see the fuel injector. So here they have the fuel injector. Now only the fuel will be injected into the cylinder. The fuel injected just before end of stroke. Okay, that means when the piston move up, okay, when did not reach yet the part, okay, so this here the fuel will be injected. Okay, A, both of the valves are closed, the piston move up and compress the air which become very hot. Okay, like just now, same one, the particle between the air will be collect. The collection of the particle will produce the hot energy, the heat or hot energy. And just before the piston reaches the top, the fuel injector inject diesel into the hot compressed air. So here we go to from here we go to the third power stroke. So the third one is a power stroke. Fuel and mixture of air will be burned. Okay, why burn? Because here is too hot, right? When the fuel is injected, so it will be burned. So both of the valve is still closed. The mixture of air and diesel burn due to the high pressure. Force of the expanding gases push the piston down. So that is the power stroke. That is the burning inside the cylinder. Then go to the exhaust stroke. You can see the exhaust stroke, the inner valve closed. That means the exhaust valve will be open. So a piston move up and push the exhaust gas out through the exhaust valve. A new induction stroke starts when the piston move down. So you can see the difference between the diesel engine and engine. So we look much more deeper to the differences between the 4-stroke petrol engine and the 4-stroke diesel engine. Okay, you have to give the aspect. So you have the 3 column here. Okay, the third, the middle column, so that the suitability, size of engine, noise product, efficiency, input through the inner valve, method of ignition. Okay, for suitability, so this petrol engine suitable for light vehicles such as car or motor car. For the diesel engine, is suitable for very heavy vehicles such as buses, lorries, and trucks. Okay, size of engine for the petrol, they are smaller and lighter. Okay, smaller and lighter of engine of the same power, but in the diesel engine, the engine is larger and heavier, even though they will produce the same power. Okay, noise noise produce engine for the petrol is the engine is quieter than when switched on, but for the diesel, the engine is noisier when switched on. Okay, efficiency. So for the petrol, less efficient and waste more petrol. Less efficient and also it will waste more petrol. But in the diesel, more efficient and waste less diesel. Okay. Input through the inner valve. For the petrol, the thing that enter the inner valve is the air and petrol vapor. But in the diesel engine, only air enter the cylinder. There is no diesel will enter the cylinder. Okay, no diesel will be enter in the first stroke or induction stroke. Okay, method of ignition. Okay, mixture of petrol and air is ignited by the spark plug. So for the diesel, there has no spark plug, but the heat from the compressors of hot water air ignite the diesel injected by the fuel injector. So that is the 1, 2, 3, 4, 5, 6 differences between these two 4-stroke petrol engine. So now we go for the 2-stroke petrol engine. Okay, 2-stroke petrol engine. Okay, it uses a small machine. It's used for a small machine such as motorboat, motorcycle, lawnmowers. Okay, so it is an inlet tube for the petrol air mixture go in, and an outlet tube for exhaust gases to escape. So they have two. They have the inlet tube and the exhaust tube, meaning they have no valve. Okay, so the inlet tube and the outlet tube are open or closed by the piston moving up and down. Okay, so this piston has the has a door for these two tubes. Okay, when the piston move down and up, so the inlet and outlet tube will be open and closed. Okay, so this is the diagram of the 2-stroke petrol engine. Okay, look at the first one. So we have two stroke, upward stroke and the downward stroke. Very easy. You have the upward stroke. The first one is upward stroke and the downward stroke. So when the upward stroke, it will the piston up, moving up, it will open the inlet tube of the petrol and mixture to enter. So the petrol and mixture will enter, and we have the petrol and air compress here. When the piston up, of course there is the compression occur. So we have the spark plug. Okay, so in this part, the spark plug, okay, move to the second stage. Okay, second stroke. When the spark plugs, the spark from the spark plug, so it occur the combustion inside the cylinder. So the piston will push down. Okay, when the piston push down, it will open the outlet tube for the exhaust gases to escape, and at the same time, this piston will allow the air and the petrol to enter the cylinder by passage of the petrol mixture to move up. You can see there, written there, passage of the petrol and air mixture to move up when the piston is down. Okay, now more detail for the upstroke and the downstroke. The piston move out of the cylinder, the inlet tube open, and the petrol air mixture enter the cylinder due to the low pressure in the cylinder. Piston close and the outlet. Piston close the outlet valve tube, meaning the inlet tube is open. Okay, petrol air mixture above the piston is compressed by the rising of piston. Okay, for the downstroke, what happens? When the piston reaches to the top of the cylinder, a spark fire by the spark plug ignite the petrol air mixture in the upper part of the cylinder. The force of the expanding gases push down the piston down, opening the outlet tube and allow the exhaust gases to escape. So third, the piston close the inlet tube as it is moving down and force petrol air mixture into the upper part of the cylinder through the transfer passage. Okay, so what is the difference between 2-stroke engine, petrol engine, and 4-stroke engine? So first of all, this is the vehicle using it. For the 4-stroke engine, they are used in motor car. For the 2-stroke engine, used for the motorcycle and lawn mower. Efficiency for the 4-stroke is more efficient and more powerful, but 2-stroke less efficient and less powerful. Fuel wasted, okay, less wasted, but for the 2-stroke is more waste. Okay, inlet and outlet for the petrol engine, 4-stroke petrol engine has inlet valve and exhaust valve. But in the 2-stroke, they have no valve, they has an inlet tube and the outlet tube. Combustion of fuel is take 4 strokes to burn the fuel and get rid of the exhaust gases. But inside the 2 stroke, they took 2 strokes to burn the fuel and get rid the exhaust gases. Okay, part of the petrol air mixture. Okay, for the 4-stroke petrol engine, the petrol air mixture enter the combustion chamber directly through the inner valve. But in the 2-stroke petrol engine, the petrol air mixture enter the space below the piston through the inlet tube, and is then transferred to the combustion chamber through the piston above the piston through a transfer passage. Okay, so there is also 6 differences between 4-stroke petrol engine and 2-stroke petrol engine. Okay, now we look at the relationship between the engine and the motion of the vehicle. So how transfer the motion in the car? So when the engine car is started, the piston move up and down and rotate the crankshaft. Okay, when the gear is engaged, the crankshaft is connected to the transmission system, which is clutch and gearbox, and the draft shaft. The rotation of crankshaft rotate the drive shaft, the differential gear, and the wheel axle, causing the wheel to turn. So look at the diagram here. Okay, the pathway, okay, from the engine, right, to the, when the engine rotate, is also rotate the crankshaft, then transfer the transmission of the system into the drive shaft, then go to the differential gear, and the wheel will be rotate or turn. Okay, so this is the diagram for the motion is transferred in the car. Here you can see the engine. Inside here you have the transmission system, which is located of your clutch and gearbox here. And you have the drive shaft and the axle and the wheel. Speed in bahasa Melayu is a kelajuan. So kelajuan is speed, velocity. Had laju is a velocity. So for the had laju, we have meter per second, kilometer per second. Normally you use it in the car, right? Right. So now we go for the acceleration. Acceleration in bahasa Melayu is pecutan. So the change of the velocity, perubahan had laju. So that one is a pecutan. So the acceleration of moving body is the change in velocity per unit second. So SI unit for the acceleration is the meter per second. So meter per second, look at meter second power of 2. Okay, how they come out with the power of 2? Velocity equal to change in velocity over time taken is equal to the final velocity minus with initial velocity over time taken. Okay, now look at the example, how to use this formula. Okay, a car starts from rest and accelerate at 5 meter per second for 10 seconds. What is the final velocity of the car? Okay, so from the question, we have to take the point there. First of all, the word start from rest. So meaning of start from rest actually shows that it start from the not moving. So the velocity is a 0 meter per second. Okay. Second one, the point is the accelerate at 5 meter per second. So meaning they already give us the acceleration value. So the time taken is 10 seconds. So we just use the formula acceleration equal to final velocity minus initial velocity over time taken. Okay. So acceleration they already give to you is 5 meter per second equal to final velocity minus initial velocity. So final velocity is the velocity that we are looking for over 10 seconds. So final velocity is equal to 5 time 10 meter per second. So we get the answer is 5 meter per second. So here acceleration meaning in bahasa Melayu is pecutan. Memecut. Pecutan. So this is the characteristic between speed, velocity and acceleration. Okay, hopefully this table will make you more understand. Okay, for the unit SI used for speed is meter per second, velocity also meter per second. Then look at the acceleration, you have meter per second, power of 2, that means meter per second. Okay, because here we have two velocity, right? So magnitude for speed, velocity and acceleration, these three things are having their own magnitude. So direction, for speed there is no direction, but for velocity and acceleration there has in a fixed direction. Okay, type of quantity, that one is scalar. Velocity is and the acceleration, they have the vector. Vector mean they are having direction. Okay. Now we want to learn more about the ticker tape to determine the velocity and acceleration. First of all, you have to get to know what is ticker timer. Okay, ticker tape and ticker timer. Okay. First of all, you look at the diagram. Okay, the ticker timer, the whole thing is the ticker timer, which they have the vibrator carbon disc. That means they will, every time it vibrate, it will produce the dot on the ticker tip. So you can see the strip there, the direction of tip. That one is a ticker tape, and we have the ticker timer. The thing is a ticker timer. Okay, behind there you can see 6 volt and or until 12 volt. That one is a supply of the electric. So electric use is the alternating current. It's not the direct current. Okay, number 1, a ticker timer is used in the laboratory to determine the velocity and the acceleration of moving body. So in the laboratory, you want to calculate the velocity or acceleration, we always use ticker timer. Okay. Secondly, if the alternating current used to operate the ticker timer, so it has its own frequency, which is 50 Hz. The vibrator print 5 dots on the ticker tape per second. Then the time between any two consecutive dot is 1/50 second, for example, or you can say it 0.02 second. Okay, so let me explain more. Meaning, in 1 second, the ticker timer will printed 50 dots in the ticker tape. Okay, so when you count the tape, on the tape, they have 30 tape, shows 30 dot, shows that the the trolley or the body moving about 1 second. Okay, so meaning from the 1 dot to another 1 dot, it shows time. Actually, it shows time. Okay, 1 dot to another dot. So 1 dot to another dot, it shows is 1/15 dot. Okay, 1/15 dot. So actually it's a 1/, in 1 second we have 30 time of dot. Okay, 50 dots. So 1/50 actually is equal to 0.02 second. That means from the dot we know the time taken for this body to move. Okay, so to interpret the ticker tapes, okay, so this is very important because in your SPM, normally they will give you the diagram of ticker tape. So you have to understand, know how to interpret. So we go for the first one. The direction of movement is from my left to right. Okay, so pattern, you can see uniform distance between two consecutive dot. That means and the pattern is uniform. From one dot to another dot, you can see the distance between two dots is the same. Interpretation, the uniform speed or uniform velocity. So when you can see the petal with a dot which is same length, meaning the speed or the velocity of the moving body is the same. There is no acceleration. Okay, so for number 2, you look at the tape number 2 from the far distance between two dots to short distance between the two dots. So for your information, far distance of the dot showing that this is the fastest one. Okay, for the very near dot shows that the body is moved very slow. Okay, so distance between dot increase uniformly from the low to speed, low to high speed. Okay, speed or velocity increase in uniformly. Okay, for the third ticker tape, you can see from the very near dot to the farthest dot, right? So the near one is from the slow to faster. Okay, to start from the first tick. Okay, the first one. The distance between dot increase uniformly from the slow to faster. Slow to faster. Slow, which one? Slow is the a distance between the dot, right? The far distance between the dot, but the faster one when the dot is nearer. Okay, so it start from the in front, Start from the in front. So the faster to slower. So that means the speed is decreasing uniformly. Okay. Okay, now we go to the diagram. Because diagram is very important also. So when you cut the strip, okay, the strip of the petal, okay, with the same tick. That means, for example, this one you have the 10 tick. So you can see the length of the petal is the same, shows that uniform speed of the velocity. Okay, for the second one, uniform acceleration. Okay, so this stripe also have 10 tick, 10 tick, 10 tick. So each of the stripe are having 10 tick. Okay, so from the shortest strip to the longest strip, meaning there is this acceleration. So the body moving faster and faster. So the diagram we call it as a increasing in speed or velocity. Okay, so uniform deceleration. This one is negative deceleration. Negative acceleration also we say it has a deceleration. So same like just now, all the strips are having 10 tick each. From the longer one, that means the slower, to the shorter one, which is a faster. Slower to faster meaning deceleration. But in the last diagram, look at the diagram, right? Okay, you can see first the increasing in speed, after that the increasing, after that decreasing. So variant acceleration and deceleration of that. Okay, now we're going to calculate the average of deceleration by referring the tape. Okay, the tape. Okay, the ticker tape graph shown below is obtained in an experiment using a moving trolley and ticker timer, which is 50 Hz current. Okay, calculate the average velocity of the trolley. Girl, first of all, you have to analyze the diagram. Okay, analyze the graph. First one, the length between each stripe has 10 tick, right? So the length is 5.2, 5.0, 5.4 and 5.6. Even though this 4 stripe has a same number of tick, which is 10. Okay, For your information, how to count the tick, right? Okay, let's say from one tick to another tick, I mean from first dot to second dot, actually we count as a first tick. Okay, for example, Monday to Tuesday. So how many days? Is it 2 or 1 days? Actually 1 day. Monday to Tuesday is 1 day. Tuesday to Wednesday, another 1 day. That means 2 days already. Wednesday to Thursday, 1 day. That means 1, 2, 3, 3 days. Thursday to Friday, another 1 day. So actually, even though we are counted 5 days, actually the duration is only 1, 2, 3, 4. 4 days only. So same lah. So when they talk to the time is 11 tick, it shows they have the length between is a 10 tick. Okay. So how to count the average? Okay, look at the solution. Total distance travel, you have to total up the distance. Okay, the length of the strip is the total distance. So you add all the length, you have 21.2 cm. Total time taken. So 4, which is a number of strip, 4 strip time 10 is a 10 tick. Actually they have 11 dot times 0.02 second. Why 0.20 second? Because the time from one dot to another dot is 0.0 second. Okay, remember or not, 1/50 is 0.02 second. So the answer is 0.8 second. So now we have the travel distance is 21.2. The total time taken is 0.8. Average velocity is distance travel over time taken. So equal to 21/2/8, 0.8 meter per second. So the answer is 26.5 meter per second. Okay, girls? I hope you understand. We go for the next work example. Also, they are using the ticker tape graph. Okay, the ticker tape graph shows below is obtain an experiment using a moving trolley down an inclined plane. Calculate the average acceleration of the trolley. Okay, look at the graph. You have the acceleration of moving a trolley from 5 to 8 cm. So you can see the strap is increasing. That means the speed or the speed of the velocity of the trolley is increasing. Okay, for the solution, look at the solution. Initial velocity of trolley is 5. The first strike, right? 5/10. Why 10? Because 10 tick time 0.02. Why 0.102? Remember 1/50 seconds. So the answer is 20 meter per second. For final velocity, 8 meter per second over 10. Why 10? Because you have the 10 tick in each stripe. Time 0.02 second. Why 0.02? Because 1/50 hertz just now. Okay, now you get 40 cm per second. Okay, time for change in the velocity for 3 stripes. Why you count 3 stripes? So because just now I already explained to you about the day, right? So even though they have 4 stripes, that means it's 3 stripes. Okay. So you 3 stripes times 10 times 0.02 second. Time for the center of the first stripe to the center of the last strip is 0.6 second. Okay, so the acceleration of trolley is final velocity minus initial velocity over time taken. So the answer is 40 minus 25 meter per second over 0.6 second. So the answer is 25 centimeter per second Okay. That's all, girl, for today. And we will continue for the second part of this topic. Good luck, girl. If you do not understand, you always can message me. Thank you. Bye.